Okay, our next problem we're asked, what is the pH of a 1.0 times 10 to the minus 3 molar potassium hydroxide solution? Okay, to solve this formula, we need to use our formula Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. The hydroxide ion concentration is 1.0 times 10 to the minus 3. Our Kw is equal to 1.0 times 10 to the negative 14, which is equal to our hydrogen ion concentration times 1.0 times 10 to the minus 3. When we solve this here for H plus, we'll have 1.0 times 10 to the negative 14 divided by 1.0 times 10 to the negative 3, which is equal to 1.0 times 10 to the negative 11. So the hydrogen ion concentration is 1.0 times 10 to the negative 11. We now take our formula, pH is equal to minus the log of the hydrogen ion concentration, and we substitute the 1.0 times 10 to the minus 11 back into the equation. So we have pH is equal to minus the log of 1.0 times 10 to the minus 11, and we know that pH is going to be equal to negative, take the log of this is minus 11, which is equal to 11. Alright, let's take a look at another problem. It says, what is the hydroxide ion concentration of solution with a pH of 9? So now in this particular problem, what we're going to do, we have pH is equal to 9, and we want to find the hydroxide ion concentration. So if we use our formula, pH is equal to minus the log of the hydrogen ion concentration, we can find our hydrogen ion concentration by saying 9 is equal to minus the log of the hydrogen ion concentration, multiply both sides by negative 1. So negative 9 is equal to the log of the hydrogen ion concentration, and then take the anti-log of this, which will say 10 to the minus 9 is equal to the hydrogen ion concentration. Knowing that, we can now use our formula Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. Substitute this into the equation, and we know Kw is 1.0 times 10 to the negative 4. So the hydroxide ion concentration would be equal to Kw over the hydrogen ion concentration, which is 1.0 times 10 to the negative 14 divided by, this is 1.0 times 10 to the negative 9, which means that the hydrogen ion concentration would be 1.0 times 10 to the negative 5. Okay, let's take a look at this equation here. It says, what is the pH of a 2.5 times 10 to the 4 molar HNO3 nitric acid solution? So in this instance, this is a little different from what we've seen before. We have pH is equal to minus the log of the hydrogen ion concentration, but the hydrogen ion concentration is 2.5 times 10 to the minus 4. So pH is equal to minus the log of 2.5 times 10 to the negative 4. Take the log of this. When we take the log of this, we will get a negative minus 3.6, which means that our pH would be equal to 3.6. Alright, let's take a look at one more problem. It says, what is the hydroxide ion concentration of a solution with pH 4.95? So again, using our formula, pH is equal to minus the log of the hydrogen ion concentration. We're told that pH is equal to 4.95, so 4.95 is equal to minus the log of the hydrogen ion concentration. Multiply both sides of the equation by negative 1 minus 4.95. 4.95 is equal to the log of the hydrogen ion concentration. Take the antilog, it's 10 to minus 4.95 is equal to the hydrogen ion concentration. Now, knowing that information, we can go back into our equation using our ionization, our KW formula for water, ionization constant for water. KW is equal to the hydrogen ion concentration times the hydroxide ion concentration. Solving for OH, we will have KW divided by H plus is equal to the hydroxide ion concentration. And if we substitute the numbers back into the equation, we get 1.4 1.0 times 10 to the negative 14 divided by 1.12 times 10 to the negative 5, which is equal to 8.9 times 10 to the negative 10. Alright, okay. This hydrogen ion concentration is 10 raised to the negative 4.95. This here, when you take it to the power or use your calculator, you will get 1.12 times 10 to the negative 5. So that's where that number comes from. That's equal to the hydrogen ion concentration. Alright, that's a wrap.